Okay, in this video we talk about a second format for the equation of a line. We've already been talking about equations in slope-intercept form, y equals mx plus b. There's a second format that we deal with called general form. General form involves your a, b, and c, your equation being in the form ax plus by plus c, where those a, b, and c are integers. And more formally, in the most formal sense of general form, the a coefficient has to be positive. This kind of harkens back to a time when you were actually writing equations on a typewriter, probably, or even on some older word processors. It's really hard to write fractions. So you would eliminate the fractions and put the equation in the form ax plus by equals c. And again, this where a, b, and c are integers, so no fractions. And then more formally, they didn't like the leading coefficient to be negative. I'm not really sure why that was the case, but it is. Now some textbooks will treat this a little more differently. They'll just say, hey, x and y have to be on both sides. It doesn't even matter if you have fractions, negatives, or anything like things like that. But here we're going to talk about the most general case, because if you can do that, then you'll be fine for the situations where they're not quite as restrictive. So consider an equation, y equals 2/3 x plus 3. And the first thing we're going to say to ourselves is, well, if we're going to have it in this general form, we can't have fractions. So we take and multiply the whole equation by 3. Okay, so we multiply everything by 3 to get rid of the fractions. So we would get 3y, and then the 2/3 and the 3 would cancel, and you'd be left with just 2x. And then don't forget to multiply everything by 3, so that's not plus 3 there. That should be plus 9. So be very careful to avoid that really common mistake there of forgetting to multiply everything. A lot of people will multiply the y and the x, but then maybe forget to multiply the number by that 3. And then we just continue from here trying to get the equation into the right format. So now that we have 3y equals 2x plus 9, we now begin to try to get the equation into the format that we want. So we subtract off the 2x to get the x on the other side. And so we subtract 2x from the other side as well. That would give me a negative 2x plus 3y. And then on the other side, we'll just have 9. Oops. So at this point, the equation's almost in that format. And again, depending on who you're dealing with, what your textbook or teacher's requiring, you would want to, now at this point, okay, the x and y are on both sides. We want to get rid of that negative sign. So we'd multiply both sides by a negative 1. And when we do that, we'd get 2x minus 3y equals negative 9. Okay, so that's the basic process for taking an equation from slope-intercept form and putting it in this general form. Let's consider a second example. Here we have the equation y equals negative 3/8 x plus 2/5. So again, we would begin by getting rid of the fractions. Now you could, if you want, go ahead and get the x and y on the same sides if you want, and then worry about getting rid of the fractions. But let's get rid of the fractions first. So we'd multiply both sides by our common denominator, which would be 40. When we do that, we'd get 40y. And then 40 times 3/8, the 40 and the 8 would cancel. It would be 5. 5 and 3 would be negative 15x. When we get to the 2/5, the 40 and the 5 would cancel to be 8. 2 and 8 would be 16. Okay, and then we want the x and y on the same side. So we would take that negative 15x and add that to both sides. That would give me 15x plus 40y equals 16. And now this time, x and y are on the same side, and I don't have that negative sign in front, so I can just go ahead and write that as 15x plus 40y equals 16. Okay, and so that's the general process. And again, some textbooks will be a little more lenient with how they accept the answers. Some of them just require x and y to be on both sides. Others require them to be on both sides, but no fractions, but they don't care whether the first term is positive or negative. And then again, the most restrictive definition is what we've looked at here, and that is they want the x and y, the x to be positive. Okay? All right, till next time.